Welcome back to the deep dive. So if you've been, experimenting with generative AI, but you still feel like you're just typing one-off requests into a fast chat bot, this deep dive is really for you. We're not just looking at AI as a singular tool today. We're looking at the crucial structure you have to build around that tool to make it consistently valuable.
Exactly. We're moving past that stage of just, dazzling individual performances.
Right. Our mission today is to take this stack of sources on AI workflows and figure out how to move beyond that simple sort of rudimentary usage to truly orchestrate AI for a massive, repeatable competitive advantage.
hmm
And the central premise, which really is key to all our sources, is that the true advantage. It isn't having access to the most powerful model. It's knowing how to organize and sequence its power.
It's the critical distinction, really. It's like a high school prodigy playing a dazzling solo versus a full professional symphony delivering a complex concerto.
Okay, I like that.
And when we talk about an AI workflow, we're defining that underlying structure, the sequence that connects multiple AI tasks, specialized tools, even different models,
Yeah.
all to solve a really complex professional problem from end to end.
And the ultimate goal of building that structure, is it just speed?
Well, it's about maximizing accuracy and consistency while, and this is key, radically minimizing unnecessary human intervention in the low-value spots. The sources use this beautiful analogy. If AI is that virtuoso musician,
Mm-hmm.
the workflow is both the score, the detailed instructions, and the orchestra direction that brings it all together. It turns isolated notes into a masterpiece.
Okay, let's unpack this with what you called the efficiency mandate. Why should we invest all this time and effort into writing this complex score?
Well, the sources make the case pretty clear, and they use hard numbers.
Right.
Yes, studies from institutions like MIT, Stanford,
Mm-hmm.
they're cited across these papers.
Mm.
And they demonstrate that structured, well-designed AI workflows can increase productivity in sophisticated problem-solving tasks by up to 40%.
40%. Okay, that is not marginal. That is fundamentally shifting the competitive timeline for any organization that can master this.
Absolutely. If you're reviewing legal contracts or, say, performing scientific analysis, that kind of jump means you can scale production without just hiring a massive new team.
But let's clarify something for you listening. This isn't just simple automation, is it? We're not just talking about moving a task from point A to point B faster.
No, not at all. An intelligent workflow is highly adaptive. It's self-correcting. The sources actually point to an even more ambitious goal within this framework, a 60% reduction in the time professionals spend on those repetitive, low-value tasks.
A 60% reduction in drudgery, that's huge. But building the complex workflow itself, the score and the direction, that takes time. Doesn't the overhead of designing all that complexity, doesn't that potentially negate some of that 40% gain? Especially for smaller teams.
That's a crucial question. And the answer really lies in their optimization objective. The goal isn't just execution, it's intelligence amplification. These flows use AI, and this is critical, to filter and prioritize massive amounts of raw, complex information. So the human professional, they still make the final high-stakes decision. But the workflow ensures they receive a highly refined signal, not just a wall of data noise.
So the professional shift isn't about outsourcing the entire job.
No.
It's about outsourcing the effort of finding what's actually important in the first place.
Exactly. The ultimate goal cited is standardizing processes, whether that's scaling academic research output or increasing the velocity of content production without, compromising depth. If you achieve that 40% productivity leap, you're not just working faster, you are working at a higher level of insight consistently.
So to get to that level of productivity, that kind of depth, we have to look at the practical anatomy of an elite workflow. We have to abandon that sporadic single prompt conversation we've all been using and move toward process chaining. What's pillar one?
Pillar one is task decomposition, or what the sources call atomicity. It just means breaking down the goal into the smallest, most specific individual components possible.
So we stop asking the AI to do a giant, complicated thing.
Right.
And instead, we ask it to do 1,000 tiny sequential things.
Precisely. And this is probably one of the most important technical insights in the source material.
Mm-hmm.
Academic evidence from computer science shows pretty conclusively that large language models perform significantly better. They maintain consistency when they're assigned small, specific, atomic parts of a larger task.
Why is that, though? Does it have something to do with the model's working memory, so to speak?
It does. It fundamentally reduces what we call context window clutter. By forcing the model to complete one discrete task like summarize this single source or verify that single fact, you prevent it from experiencing catastrophic forgetting or, logical drift mid-task. You're maximizing its accuracy by constraining its scope at every single step.
The sources have that fantastic example of this. It's really memorable. If you need a comprehensive 50-page report, the amateur prompt is just...
Write a 50-page report,
Yeah.
which, as we know, gives you a generic, often hallucinatory result. A professional workflow breaks it into at least 4 separate constrained steps.
Okay, what are they?
So, Step A, extraction and verification of all external sources and raw data. Step B, creation of a detailed logical scheme or an outline based only on that verified data. Then Step C is modular drafting, section by section, making sure each section sticks to the scheme. And finally, Step D, a final review agent that checks for style, consistency, and citations across the whole thing.
That detailed breakdown, that leads us right into Pillar 2, the architecture of agents. And this connects back perfectly to our orchestra analogy. If we have 4 atomic tasks, we can stop using AI as a generic tool and start using specialized, dedicated agents.
Think of it this way. Instead of one single, overwhelmed AI model trying to do everything, you have a team of highly specialized components. Each agent has a focused capability, it knows its instrument inside and out, and it handles one specific part of the workflow.
The sources use a really relatable example, something like producing a complex investigative podcast.
They do. They break down the roles you'd need. First, you need an investigator agent. Its job is purely research. It's accessing specialized proprietary databases, maybe academic repositories like Archive for physics or PubMed for medical research.
And then after that, you'd need a scriptwriter agent. Its whole purpose is to adapt the tone, the style, the structure of that super technical information and, translate it for a broad public audience.
And, crucially, you need a dedicated quality control specialist, the fact-checking agent. Its only role is validation. It checks the outputs of the main generating models against the original source data to actively hunt down and flag hallucinations or any inaccuracies. This kind of built-in quality control structure is it's non-negotiable for any high-stakes output.
Okay, so if that investigator agent is tasked with searching these specialized databases, that brings up the question of context immediately. And that leads us to Pillar 3, the need for a smart layer, focusing on dynamic context. Why should we rely on the AI's base training if that data is 6 months or even 2 years out of date?
We simply can't. You can't, especially in fields like science or finance or anything that's rapidly evolving. Relying on stale general training data is basically malpractice. Professional workflows demand dynamic context. That means the AI has to be able to pull in current, relevant, specialized information before it generates its response.
And the technique that makes this real-time consultation possible is called RAG, right?
Right. Retrieval Augmented Generation.
Yeah.
RAG is that critical layer that lets the AI consult those specific external databases, the ones the investigator agent is using in real time. It's what bridges the gap between a model's generalized knowledge and your specific proprietary or highly current knowledge base.
So why is RAG such a game changer for the professional listening to this?
It guarantees accuracy and currency. If you are drafting a legal memo or underwriting a financial risk or providing medical guidance, RAG ensures the information being used has scientific or legal backing and is up to date. The sources specifically noted that RAG implementation could guarantee facts were current as of, I think it was January 2026. If you operate in a high-stakes environment, RAG moves from being a nice-to-have to being absolutely non-negotiable.
And this whole highly technical architecture, it circles right back to one of the initial goals, which is implementing human-in-the-loop systems, or HITL. So while the workflow aims for minimal human intervention, it's actually designed to make sure human oversight is applied where it's most needed.
HITL is essential, and it's not a failure of automation, it's a robust design feature. It's necessary for quality assurance, especially in complex analysis. The fact-checking agent filters and flags the priority points, the potential errors, the uncertain data, and the human professional reviews, just those specific high-leverage points. That's how you sustain a 40% productivity gain without risking a catastrophic failure.
It's so easy to focus on the 40% productivity gains and the, 60% reduction in low-value work. But as we move into this domain of autonomous systems, we have to acknowledge the challenges. The source material uses this metaphor that implementing these flows is not a garden of roses. So what are the specific risks we need to understand?
Critical thinking means understanding the downsides, for sure. The forces detail 3 major difficulties. The first, and arguably the most dangerous, is the propagation of error.
Right, the compounding interest nightmare, but with bad data. Can you walk us through a specific scenario where that could happen?
Certainly. Imagine a financial workflow designed to assess loan risks. If the very first atomic step, the investigator agent's data collection, if it fails to properly normalize the input currency or uses an outdated exchange rate, that initial tiny flaw gets fed to the analysis model, then to the compliance model, and finally to the scoring agent. That small error doesn't just result in one bad score, it magnifies down the entire automated chain. It could potentially contaminate thousands of decisions before a human auditor even sees the final report weeks later. The error scales with the workflow's speed.
That's terrifying. Speed actually becomes your enemy if the foundation is cracked.
Oh.
Okay, what's the second hurdle when you're scaling these systems?
The second is what the sources call the cost of context. As these workflows get more complex, using multiple agents, integrating RA to query huge databases, handling massive context windows, the consumption of tokens and computational energy just goes up and up. We're basically trading human salary time for machine compute time, and that machine cost is substantial.
Which raises a pretty serious question about sustainability. You get the 40% efficiency boost, sure, but at what environmental and financial cost? It sounds like it demands constant optimization just to manage the resource burn.
Precisely. If it's not managed, the growing token consumption can quickly make even a highly accurate workflow economically unsustainable. You're always trying to find that sweet spot between depth and computational efficiency.
And the third major challenge.
That would be ethics and bias. An automated flow, for all its speed, lacks any inherent reflective capacity. So if the initial training data or the design of the workflow itself reflects pre-existing systemic biases, say in automated hiring screens or loan applications, the flow will replicate and scale those biases at an alarming speed. Without specific critical human supervision points built in, that 60% time savings could become a 60% acceleration of negative or unfair outcomes.
So if we synthesize the conclusion from all this, it sounds like AI workflows really represent the maturity of artificial intelligence. We've moved from that initial fascination of, look what the chatbot said, to actually building autonomous intelligent systems that can manage enterprise-scale complexity.
And the ultimate insight is framed as both a warning and a profound opportunity. The source states it very clearly. Whoever designs the flow dominates the industry.
Yeah.
This confirms that AI is not coming to replace the professional. Instead, the professional who skillfully designs and uses these optimized AI flows. They will inevitably displace those who are still relying on manual, rudimentary, one-off tool usage. Flow design is the new source of competitive dominance.
That is a powerful concept to end on. Workflow design is the master skill of the next professional generation. Let's quickly review the major nuggets we extracted here for you. There's the proven 40% productivity boost from structured design, the necessity of atomic decomposition for model accuracy, the power of retrieval augmented generation, or RAG, for dynamic context, and, of course, the acute dangers of error propagation down that automated chain.
And that profound tension really leads us to our final thought for you. We know the driving force is that immense gain in human efficiency, that 60% reduction in low-value task time, but we also know that complexity drives up the cost of context, the growing token and energy consumption. So as your workflows get smarter, how do you successfully balance that efficiency gain against the increasing resource demands? What strategic trade-offs must you make for sustainable dominance in this orchestrated AI world?
That's something for you to mull on as you look at your own complex projects. Maybe start today by just applying the concepts of decomposition and agent specialization to one of your multi-step tasks. We'll see you on the next deep dive.